Hey guys, in this video we're going to look at the solutions to both of the practice tests for the Algebra 1 Unit 7 test, starting with practice test number 1, and then we'll move on to practice test number 2. And so question number 1 says, what's the vertex of the quadratic function below? The vertex is going to be the opposite of this number right here, -2. So that would be +2. And then that 4 right there you take as is. And so it's 2, 4. That is it. Problem number 2, the function f of x is equal to x squared is translated 5 units to the left and 3 units down to make a new function g of x. Write a function that could be g of x. So we're going to say g of x is equal to, now if we go 5 units to the left, that is going to be added to the x in the parentheses. So x plus 5 squared. And then if you want to go 3 units down, just put a -3 at the end, and then that is it. All right, number 3, same thing. We're going to translate for g of x. We want it to go 1 unit to the right, 3 up, and then we want to reflect it across the x-axis. So I'm going to do this one in steps. So the first thing I'm going to do is translate it 1 unit to the right. So that'll be x minus 1 squared. If I want to go 6 units up, I have to do a +6 to move it 6 units up. To reflect it across the x-axis, I have to change the signs of all the terms. So now I have a negative x minus 1 squared, and I have to change that to a -6 now. Okay, so I'm going to put a g of x in front, because it does have to be a function. And my final answer is going to be g of x is equal to negative x minus 1 squared minus 6. Question number 4, graph the vertex and axis of symmetry of the function. So your vertex is going to be at -1, 2. -1, 2 is where the vertex is. The axis of symmetry passes through the vertex. So it's going to be a vertical line, and I'll use red, and it's going to be dashed. And all you have to do is just graph that line. It does not say to graph the function, it just says to graph the vertex and the axis of symmetry. So that's all you have to do on this one. Pretty easy. All right, number 5, we have to actually graph a quadratic. So this one is going to be x squared minus 3. So the vertex is going to drop down 3 units. There's a 1 in front of the x squared, so we're going to go over 1, up 1. Over 2 up, 1, 2, 3, 4. Over 3 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is it. And now we're going to connect our dots. And we just make sure that we put some arrows on there, and it looks pretty good. Number 6, we're solving a quadratic equation. We're going to use square roots. First thing I would do is add 4 to both sides. So I have x minus 2 squared equals 4. I'm now going to take the square root of both sides. Plus minus, don't forget it. The x minus 2 now drops out, is equal to plus or minus. Square root of 4 is 2. I'm going to add 2 to both sides, and I now get x is equal to +2 plus or minus 2. So now I need 2 answers. So my 2 answers are going to be 2 plus 2, which is 4, and 2 minus 2, which is 0. And both of those are going to be in a curly bracket. It doesn't matter what order they're in, as long as it's the set of solutions in the curly brackets. Problem number 7. First thing we're going to do for this one is subtract 3 on both sides. We're going to get 3x plus 5 squared is equal to 30 take away 3 is 27. We are now going to divide both sides by 3. Never distribute with a quadratic. We have x plus 5 squared equals 9. We're now going to take the square root of both sides. Plus or minus, don't forget it. We now have x plus 5 equals plus or minus 3, because the square root of 9 is 3. We're going to move the 5 over, and we get x is equal to -5 plus or minus 3. So I am looking for two answers. And so one of the answers is going to be -5 plus 3, which is -2, and -5 minus 3 is -8. And that is it for number 7. For number 8, it says the path of a rocket can be modeled by the function h of x is equal to -16 times x minus 3 squared plus 144, where h represents the rocket's height in feet at time t in seconds. What is the maximum height that the rocket can attain? The vertex of this function can be found at +3, 144. What that means is the vertex, this number, the 144, is the maximum height that it can have. So that's the max height. The 3 refers to the time it takes to get there. Now, of those two numbers, the one that I want for this problem is the rocket's height in feet, where it's going to be the maximum height that the rocket can attain. So for this one, I need to report this number, the 144 only. And so my answer is going to be 144, and my units are feet. Okay, so that's all 8 problems on practice test number 1. Now let's check out practice test number 2. It's the same kind of stuff. Question number 1, what's the vertex? And the vertex, again, opposite this number. So it's going to be at -5. This number right here is as is, -2. So -5, -2 is the vertex. Problem number 2, translations. We're going to move this one, g of x is equal to, we're going to move it 3 units to the right. So x minus 3 squared. And then we're going to move it 2 units up. So we're going to put a +2 at the end. Number 3, we are going to first translate it 2 units to the left. So that would be x plus 2 squared. We're going to move it 3 units down. But now we're going to reflect it across the x-axis. So we're going to change the signs of both the terms. So negative x plus 2 squared plus 3 is what my function needs to look like on the right-hand side. So my final answer would be g of x equals negative x plus 2 squared plus 3. And that's it. Number 4, we need to graph the vertex and the axis of symmetry. So that's it. So the vertex is going to be at +2, -1, 2, -1. The axis of symmetry is a vertical line that goes through that point. So it's going to look like this. It's a dashed line, just like before. And there is our axis of symmetry. All right, so now let's take a look at the backside. The backside, we now have to graph x squared minus 5. So we're going to drop down 1, 2, 3, 4, 5 units. Okay, there's a 1 in front of the x squared, so it's over 1 up 1. Over 2 up, 1, 2, 3, 4. Over 3 up, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's probably all the points that we can fit on there. So we will now connect our dots like this. And there's our parabola for number 5. Number 6, first thing I would do for that one is add 9 to both sides. X plus 1 squared is equal to 9. I would now take the square root of both sides, plus or minus, don't forget it. The x plus 1 pops out, and root 9 is 3. I now subtract 1 on both sides. X is equal to -1 plus or minus 3. I have 2 answers that I'm looking for. That's terrible, curly brackets, that's a little bit better. 2 answers, -1 plus 3 is 2, and -1 minus 3 is -4. Those are my two answers. Number 7, first thing I'd do for this one is I would subtract 1 on both sides. So I have 2x minus 1 squared is equal to 8. I'm now going to divide both sides by 2 to get rid of that 2 in front. Never distribute. So now x minus 1 squared is equal to 4. I am now going to take the square root of both sides, plus or minus, don't forget it. My x minus 1 pops out, equals plus or minus 2, because root 4 is 2. Add 1 to both sides. X is equal to 1 plus or minus 2. So I'm now looking for two answers. 1 plus 2 is 3, and 1 minus 2 is negative 1. Problem number 8. Path of a rocket can be modeled by the function h of t is equal to negative 16 x minus 2 squared plus 81, where h represents the rocket's height in feet at time t in seconds. What is the maximum height that the rocket can attain? The maximum height is going to be in the vertex, the y-coordinate of the vertex. So the vertex is at positive 2, 81, just like we did before. The 81 represents the height at time t when it gets there. So at 2 seconds, the rocket has hit 81 feet high, and then that's it. It's going to start coming down after that. So this is the one we want for max height. That's the time it takes to get there. I'm not asking for that. I'm asking for the max height. And so we're going to report our answer as 81 feet. Okay, guys, these were both practice tests for our Unit 7 test in Algebra 1. Remember to like my video and subscribe to my channel if you haven't already. And we'll see you guys later. Bye.